Okay, 2.3, we're going to do the product rule, okay? We did the power rule, and now we're gonna do the product rule, and then we're gonna end with the quotient rule, okay? Now, the product rule will seem quite lame until we get to 2.5. I'll kind of try to talk about why, but for right now, please realize that the product rule will seem like, why am I doing this? Why can't I just do it the easier way? And in point of fact, for right now, you probably can, okay? But practice, I wouldn't do it. You practice it while it's super easy. The product rule will become very useful and very powerful in a little bit, but right away it won't. So here's how it works. I'm gonna do it the same way. I'm gonna show you how it works and then we'll prove it, okay? Suppose big F can be thought of as something times something else. The derivative of big F would be the first one times the derivative of the second plus the second one times the derivative of the first. You gotta memorize that, okay? This is important. This is it. This is the rule, right? And one of the reasons you gotta memorize it is they'll ask questions in such a way that the question is really easy as long as you memorized it. Like they might say, literally, like in some of the homework questions, like, big F is F times G. F of 7 is some number. F prime of G is some number. G of some number of 7. Oh, no, what's I said again? F of 7 is some number. G prime of 7 is some number. G of 7 is some number. F prime of 7 is some number. What would the derivative be? As long as you can put everything in the right spots, you get the answer. So some of the homework will literally be memorize this formula. Okay. Now, here's how this works. And you're going to go, Mr. Peters, you just told us on the last question that we could actually FOIL it out and do it by using the power rule. Yeah, you can. But here's the rule. Here's the rule. The rule says first, this is the derivative. Now there aren't going to be to be honest, most of the questions that we do in this 2.3 will be the power rule. Because until we learn some trigonometry and until we learn something called the chain rule, the power rule doesn't really seem that the product rule doesn't seem that useful. So just be aware of that, okay? I think I probably already said that to start with. This seems quite useless right away. But anyways, just trust me that it will be valuable later on. First, and then times the derivative of the second, and then the derivative of this one is 5, right? The derivative of that. So notice we're doing a power rule here. Plus the second one, following the rule here, plus the second function. And then last but not least, times the derivative of the first, which is x, which is 2x. The derivative of x squared is 2x, the derivative of 3. So its first function times the derivative of that function plus the second function times the derivative of the first. And then you work that out. 5x squared plus 15 plus 10x squared plus 14x. So what is that? 15x squared plus 14x plus 15. Just collecting my like terms here. 5x squared plus 10x squared is 15x squared, and then putting them in descending order. Now, if you remember what I said, you don't practice it this way when you get the chance, so that when they get more challenging, that you could do it. You could FOIL it out. First times first. I just want to show you that what you might be thinking. Outside times outside plus 7x squared. Inside times inside. 15x. Last times last. 21. And you might be thinking, Mr. Peters, why can't I just take the derivative? Oh, right here. Here. Oh, crap. What's 1 times 5? That's 5, not 15. So take the derivative here. 15x squared plus 14x plus 15. So yes, okay, you guys, for right now, you might think the power rule isn't all that freaking useful, but it's more useful than you might think. Okay? Well, it will become much more. Now here's where it's going to come. Think about it this way. Foiling that out wasn't that hard. What if this was the case? It would take us all day to FOIL that out, all day to FOIL, and then multiply it together. It would take forever, right? We're going to be able. We're going to need something called the power rule to deal with that 7 and the 9. But we're going to be able to take this derivative very quickly within seconds. Okay, about as long as it will take to do this one. About exactly the same, maybe even less. Okay, so just be aware that you got to trust me on this. That this rule becomes important, but initially isn't, because we don't know enough other rules to make it useful. So anyways, but this is it. This is it. Take the first one times the derivative of the second plus the second one times the derivative of the first. This is the product rule. Now why is that? Let's do a proof of it real quick. Okay, so if we assume big F, we want to show that we get this, right? We want to show that we're going to get this, right? So let's do the now when you do proofs with derivatives, you got to go back to the definition. Remember, the derivative of this is f of x plus h minus f of x over h, but it's very specific. It's f times g. So this is the derivative of that. So I want to show that that becomes f g prime plus g f prime. That's what I have to do. Now, this first step, make sure you understand it, but you don't have to know why we did it. I mean, it might not be obvious, right? For some of you, it might be obvious why I did it. Who knows? First step here. First step. Now here's the thing. I never would have thought of doing this. I'm going to move this all the way down here. Over h. What I'm going to do here, and don't panic if you're like, oh, why in the hell is he doing that? Don't worry if you don't know why I did it. Make sure that you realize I could do it. I'm going to subtract f of x plus h, g of x, and then add the same exact amount. Now, make sure that if you don't panic, like, why are you doing that, Mr. Peters? Trust me, I'm heading somewhere with it. But just make sure that you understand that what I just did is within the rules of the game, right? I subtracted something and I added the same thing. So like I subtracted 7 and added 7. So basically I didn't do anything. Basically, for a lack of a better way of saying it, this is a gigantic 0 that I added, right? Now, what I'm going to do is I'm going to break it up right here at this plus sign. Okay? I'm going to have the limit as h goes to 0, f of x plus h, g of x plus h, minus f of x, h. I'm going to stop there and put that all over h. And then I'm going to break the second half of it off as its own question, in a sense. And some of you might be able to see what's going to happen here. Notice that they have a common factor. So I'm going to factor it out. Here and here. And here it has the common factor of g. Do you see it? We're done, right? We're done. Now, if you don't see it, don't panic. But if you see it, that's good. Okay. What is this? The limit as h goes to 0 of f of x plus h minus g. That's the definition of the derivative. That's the definition of the derivative, right? Because we're taking the limit. It's good enough. So I get my g of x. Hey, that's just the definition of the derivative again, but for g. But h is going to 0. Ta-da! F g prime plus g f prime, and we're done. There it is. Okay, that's it. That's the product rule, and then next is the quotient rule. Proof's a little more complicated, but along the same lines.